Okay, good morning, everybody. I hope you guys are doing well. Uh, hopefully you enjoyed your no lecture day, and it was just a little bit of a work day as we would have normally had if we were in class together. So today we're going to talk a little bit of application for logarithms. This problem isn't too bad. It deals with space. Backing up though real quick, just to tell you a couple places where logarithms are used and you may not realize it. The Richter scale that is used to measure how strong an earthquake is a logarithmic scale. pH, that measures the pH in water, for instance, if you remember from chemistry, that is a logarithmic scale. Um, Another scale that is a logarithmic scale is decibels. So when you're measuring the loudness of music, that is also a logarithmic scale. And what that means is it is not a linear growth. So for instance, if you're looking at a Richter scale, if you have an earthquake that is a 3 versus a 5, you would think, oh, it's 2 more than the 3. Yes, that is true. But when you go from a 3 to a 4 on the logarithmic scale, I'm sorry, on the Richter scale, which is a logarithmic scale, that is actually from 3 to 4 a 10 times greater amount. So when you have a 3 compared to a 4 is 10 times greater than a 3. So when you go from a 3 to a 5, that is times 10 times 10 greater. So a 5 on the Richter scale is actually 100 times more powerful than a 3 on the Richter scale. So that's the way the logarithmic scale works. It's an exponential growth instead of just a linear growth. And you can hopefully visualize what an exponential function looks like, but it's very significant difference between each of the measurements. So when you are, let's talk about this one now. It says one method for determining how X and Y values for a set of nonlinear data are related is to take the natural log of each of the X and Y values. And so they very specifically in here said X and Y are data points, but they are not related linearly. In other words, if you plotted those points, they would not line up in a straight line on a scatter plot. There are other types of data in the real world. It says if the points when graph fall on a line, then you can determine that the X and Y values are related by the equation natural log of y equals m times the natural log of x, where m is the slope of the line. So when you take the natural log of the data points and you get your new data points, that's when they will look linear. But themselves, they are not linear. So this table shows the mean distance from the sun, x, and then the period y, the time it takes a planet to orbit the sun for each of the 6 planets that are closest to the sun. In the table, the mean distance is given in terms of astronomical units, where Earth's mean distance is defined as 1, and the period is given in years. So find an equation that relates x, y, and x. So if we look at Mercury, what this is saying is Earth, we're calling the distance from Earth to the sun 1 unit. So if from Venus, the mean distance to the sun is zero point 0.7, that means it's closer than it is than the Earth is to the sun. And Mercury is even closer yet. It's only 0.3 of that distance. Now, the period is our one time period, 1 year. So for us, we are mean distance 1 away from the sun, and it takes us 1 year to go all the way around the sun and complete a cycle of seasons, right? On Venus, they're 0.7, so they're much closer to the sun. If you can hopefully visualize that, that means the big circle that it makes around the sun is going to be a smaller circumference. Therefore, it takes less time for Venus to make an entire trip all the way around the sun. It only takes about 2/3 of our Earth years. Mercury is much even closer yet, and it only takes about a quarter. It only really takes about 3 months for Mercury to make an entire loop around the sun. Now, on the other side of that, Mars is farther away from the sun than we are. It's about 1.5 times the distance. Jupiter is 5.2 times the distance away, and Saturn is 9.555 times the distance. And so you can then hopefully be able to visualize that the sun is the center of the universe, and the further you get away from the sun, the center, when you're making that trip all the way around the sun, it's going to take you a longer period of time. Now, it is not a perfect circle. It is actually an ellipse. Um, but you can see that the period of time that it takes for Mars to complete a year is 1.8 of our years, and Jupiter's 11.8 of our years. And Saturn actually takes 29 years to complete a cycle of all the way around the sun. So, looking at that data plotted, this is what it looks like. You can see these planets here are clustered together, and then we get to Jupiter and Saturn. But these are not a linear graph. These do not line up linearly. You could not draw a straight line through those and have them all line up. So, what they decided to do is to take the natural log of all of these x values and all of these y values. And then in doing so, this is what you come up with. The natural log of all the x's and the natural log of all the y's. Those are the results. Now, what's interesting is when you take these new ordered pairs, all these natural log of x's, these new natural log of y, so here's xy, 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 and we plot all of those points, you get a straight line. And so what that means is this original data is actually a logarithmic or an exponential graph. It is not a linear graph. But when we take the natural log, it turns it into a linear graph. And so the last piece of this is once we take these points right here, which are all the natural logs of the original data, and we plot them, they asked us to find the equation of this line. So this part is very simple. It's an algebra 1 problem. In order to find the equation of a line, you need to have the slope and you need to have the y-intercept. And so it's very easy to see the y-intercept. You can see the y-intercept is 0. And to find the slope, we need two ordered pairs on this line. And they said use the points 0.421, comma 0.632, and then 0, 0. And when I take y2 minus y1 over x2 minus x1, I end up with approximately 1.5 or 3 halves. So this line right here, this line's slope is 1.5. And looking back into this equation that I gave you again right here, to relate the two, it's the natural log of y equals m natural log of x. And so the equation that relates this original data, the x's and the y's, is going to be natural log of y equals 3 over 2 natural log of x. Okay, guys, hopefully that made sense. I have some practice problems for you to try. These are word problems. They are going to be challenging. I will post a follow-up video on the next odd numbered day that explains all of the word problems. Hopefully that will help you out if you have any questions on this. Hope you're all doing well. Take care.